Good afternoon, everyone. I'm Margaret Hansbrough, and thank you for joining us today. If you are in Panel 4, Session 1, State and Regional Programs and Policy, if that's where you need to be, that's where you are. Before we begin introducing speakers, a few items of housekeeping. Thank you all again to our sponsors, especially DTE, our host. If you click on the sponsor link on the left-hand page, you can learn a little bit more about their work. Today we have a really exciting lineup of speakers. After all the presentations, all three of them, we'll have 15 minutes of Q&A at the end. We'll use the right-hand column of the chat for questions only. So if you put a question in there throughout, I'll be keeping track. And if you would like to connect with any of the other attendees, you can click on the attendee link, also in the left-hand column, and you can click on their profile. And then you can also look on that same column for resources as well. You'll see the list of attendees, other information about the proceedings, and an evaluation survey. Anyone who fills that out, again, will be eligible for a discount on next year's summer study. The program participants link, you'll find information all about the presenters and their bios, which I'll also cover as well, and copies of their presentations. Last, if you can join us at the end of the day for the post-sessions debrief, should be a good, thorough discussion later this afternoon. And all of these sessions, again, will be recorded, so if you miss a session, you can watch it later. So let's get started with our first speaker, James Siegel. James is a supervisor in Eversource's Business Intelligence Group, where he supports energy efficiency initiatives. Over the last 7 years, James has designed and launched several enterprise data systems that enable insights on customer data. He's also helped develop Eversource's CNI go-to-market strategy for energy efficiency. And before Eversource, James worked for DNR International, where he helped clients at the US DOE and EPA implement Energy Star programs. James is a Master in International Business from the Fletcher School at Tufts. James, take it away.
All right, thank you, Margaret. Good afternoon, everybody. Before I dive in, I did want to say a few things about Eversource, and this is basically every utility presentation you ever see starts with a slide, but we are the largest energy provider in New England. We operate in 3 states. We're in Mass, Connecticut, and New Hampshire, with 3.2 million electric customers and almost 900,000 natural gas customers. And as an organization, very strong commitments to energy efficiency and also delivering safe, reliable, and affordable energy to our customers. Now, we operate in 3 states, but all of the data that I'm going to share today is from Connecticut. So I wanted to quickly mention how we go to market for EE in Connecticut. We do it through the Energize CT program. This is the initiative that brings together all the clean energy resources in Connecticut to help homes and businesses invest in renewables and also energy efficiency. Now, the research that we are I think I'm getting some messages that people aren't seeing the slides. Let me try this again. I guess, are people seeing the slides? I'm getting some messages that people aren't seeing them.
James, yeah, we're not quite seeing. Sorry for the technical difficulty, folks. If you can just go to that middle button there, where if you hover above it, it has a red line and a screen, and try from the start.
So it says I'm sharing. I've got a message that says stop sharing.
Let's see. Try scrolling down a bit, and maybe just try doing over.
Sure.
Yeah, just stop and then start again.
Is somebody else sharing in the group? Is that what's causing the problem?
Yeah, if yes. John McHugh, if you can stop sharing, and then the ability should go to James. Okay, John, stop sharing.
All right, let me try this again.
And start again.
How about now?
Looks good. Okay. Yes.
Excellent. All right. So I think we're in business at this point. I'm looking at the chat. So if anybody sees any issues, just throw it in the chat and we'll sort of regroup again. But the agenda that we're going to be talking about today, talk about our research, and okay, it looks like we're good to go. So the research that we are presenting on today, it showcases our segmentation analysis. And we talked about some things that we changed during the COVID-19 pandemic. And we did it all through the context of industrial customers in Connecticut, focusing mostly on manufacturing customers. So most of the data that I'm going to show today is focused on that. But I do want to mention that this was a team effort. We had 3 other people that worked on this paper: Tim Kirkman, Jason Strano, and Rachel Nadolny. And I would encourage people to review our paper for more information on our approach. Eversource has been a data-driven organization for a long time, and this is something that's more relevant to us now than ever before. It allows us to do more effective targeting as things change in our business. So for example, as our energy efficiency goals increase, or in the case of last year, when we experienced a shock like the COVID-19 pandemic. And a lot of our approach stems from the fact that we don't look at meters, we look at customers. We group meters into customers, pull the relevant internal data that we have, and then we assign segments to those customer groupings. And this is the exercise that we take that gets us to a place where we can understand who our customers really are, and also what are the opportunities and how can we access some of those opportunities. To get to that level of understanding, we have to do a lot of data integrations, and there's 3 main categories of systems that we integrate: billing, past participation, and then segmentation. The billing and the past participation categories, I sort of throw those into the legacy system bucket, in that those are things that existed a long time before we started doing any segmentation analysis. It's the segmentation systems where a lot of our data comes to life. These are the systems that we've built specifically for analytics. We have a number of different types of databases that fit into this category. Some of them are owned by our IT organization. And then we have some others where the business has more free reign and flexibility. And it's in those systems where we house a lot of our standardized data, and also the stored procedures that access all of our key systems and normalize our data in a way that we can deploy it to marketing. When we do segmentation analysis, we typically start with size. Size usually connects to opportunity. So the larger the customer, the higher the potential for energy savings. These are also the larger customers tend to also have more resources, and that means more capable of responding to some of our custom offerings. And the approach that we've taken over the years is we do a quartile analysis. And when we did this, the biggest takeaway is we realized that our data is extremely top heavy. 2% of our customers makes up 75% of the usage. So in the case of Connecticut, as an example, we might have 21,000 distinct natural gas customers on the C&I side, but it's only around 500 of them that make up 75% of the usage. So this has a huge impact on our program design. We end up having dedicated sales execs and more custom offerings available to those top quartile customers. And then as you move down this pyramid into the smaller businesses and the micro businesses, the offerings become more standardized in mass market. Next thing we do is industry segmentation. Segmenting by industry allows us to speak to specific business priorities. So what I have right here, this is electric consumption in Connecticut, just showing the top 3 quartiles, so basically the largest customers that we have. Manufacturing is 27% of the usage in Connecticut, followed by retail and then government agency. And if I were to put this together in Massachusetts, it would look a little different. In Mass, we've got all the universities and the skyscrapers in downtown Boston, so education and commercial real estate would be bumped up a little bit. But in Connecticut, manufacturing is the largest for both electric consumption and gas consumption in our service territory. So drilling down allows for more customized outreach. So this is looking at Connecticut 1 level below manufacturing. And you can see that we've got dedicated categories for certain manufacturing types. So we have aerospace, food and beverage, paper manufacturing, and then also pharmaceuticals. And then we also have this other category, basically the unclassified customers. It's really important that we have this level of breakdown. A lot of the other program administrators that we work with through our various state level initiatives have similar industry segments in place. And having this allows us to share some of our learnings and understand some of the barriers as we attempt to work with some of these customers. So that segmentation, that's really become part of our DNA over the years. Those industry segments, the quartiles, it's the foundation from which we build out a lot of our go-to-market planning. And after we spent that time to get the model up and running, we started asking ourselves, what are some other ways that we can use these segments across our business? And it was our marketing team that came to us and wanted to connect it to our project data. And the idea being that would be a way that we could put together some customer lists that have all of the data packaged together, and then we could share it with our implementation teams and just get more insights out to the staff. So we took a look at that. We took a couple of different approaches for this. I'm going to run through these examples. First is a more simplified approach. This is showing the share of electric savings over time. And we're considering the same industry segments that I've shown before. And with this, you can see that manufacturing is 26% of our electric savings over time. I like the look of this graph, but it doesn't necessarily tell me if that 26% number is good or not. So we evolved our approach and moved to this. This shows the share of savings versus the share of usage. So this is a way of indexing the data, a little bit more insightful than the previous slide. So again, we see that manufacturing is 26% of the savings, but it's 27% of the usage. So slightly under indexing as a category, whereas retail and government agency are both over indexing. And then as you move down the chart, you can see commercial real estate. That's another category that's under indexing. So we really liked this approach. It helped us understand what are some areas that we need to target, but some people wanted to see the actual numbers. So we evolved the indexing data to this. So this is another cut at indexing as an analysis. Here we're showing the savings as a percent of electric utility sales. So what we do here is we divide the savings by segment into the usage by segment. And what that does is that gets us sort of like a penetration metric or profit margin type metric. And that's just sort of a different way of doing the indexing calculation. What's great about this is the indexing percentage is normalized across the categories. So it's a lot easier for any segment comparisons that you want to do. Also, having it in this table with the usage data, you don't lose track of what are the large segments, what are the small segments. And this is another approach that works really well on customer lists. So doing that same penetration calculation, but doing it at the individual customer level, very helpful. So that's something that we've definitely standardized and gotten out to our teams over the years. But some people wanted to see a little bit more granularity on this because the savings numbers are basically just an aggregate number. You don't know what's coming from lighting, HVAC, process, et cetera. So we went one level down and we compare in this graph right here, we're comparing the usage by end use to the savings by end use. And the rationale for originally looking at this was the fact that a lot of people wanted to know how many customers were just doing lighting. So we want to understand like who's over indexing in the lighting category. How can we be more comprehensive with some of these customers? So this is the energy consumption by end use for those manufacturing categories that I mentioned before. And it's no surprise to see that most of the usage is coming from the process energy. And then here we have the savings by end use for those same categories. We did this exercise. It turned out to be, a lot more relevant for some of the non-industrial categories. Lighting and HVAC are just a tiny percent of consumption in a typical manufacturing facility. By contrast, in a retail store or an office, it's a much different conversation. But nonetheless, we did find this to be an interesting exercise. Here I'm showing what it looks like for the aerospace manufacturers. And what I have at the header of this slide is that lighting is 7% of the usage for aerospace, but we're getting 53% of our savings from lighting. So that's the type of thing that we want to drill down on and understand what's happening there. We also found some manufacturers that actually had 100% of their savings coming from lighting, and these were top quartile customers. So again, that's the type of thing that we see that data and we want to revisit our conversations with those organizations to see if we can be more comprehensive. Now, to make a long story short, I had mentioned how marketing had asked for this. We did end up packaging this as customer lists and getting it out to our team. We're really big with using dashboards and online customer lists where we package a lot of this segmentation data together and get it out to our staff. It's a way of democratizing our data and arming our implementation and sales folks with relevant information about their customers so they can be a little bit more surgical with their outreach. And we've had this in place now for a couple of years, and this is really our normal process. But as we all know, this past year was not a normal year. So here I want to show a couple of things that we looked at during the COVID-19 pandemic. One of the things that we did in our research, we compared our 2020 usage to historical averages. And we did this for our industrial customers and our non-industrial customers as well. One caveat I'll mention before I show some of the data is that we use billed usage and basically the data that's coming from our billing system. So it does not consider any on-site generation, but nonetheless, it was a fascinating exercise for us to do. So again, let me move to the first slide here. So again, we're looking at 2020 consumption versus historical averages. This graph shows you the percent change in 2020 compared to the historical average for usage by category. The blue bars represent those manufacturing categories that I had up before, and the gray bar is all segments, basically industrial and non-industrial. So a couple things jump out right away. First of all, the gray bar, all segments down 12%. So that was COVID-19 impact on our commercial and industrial customers in Connecticut. We had the 12% drop. Next thing that jumps out is that with the exception of paper, all of the manufacturing categories are either basically right at that average or better than the average. So what that says is that it was our non-industrial categories that saw the biggest drop off in consumption. The industrial categories, for the most part, did pretty well. And then, the last thing here is that paper number kind of jumps off the page, down 39%. We took a closer look at that, and that actually turned out to be more of a long-term trend. We've had some paper manufacturers move out of our territory and convert some of their sites to non-manufacturing type sites. So it was less related to the COVID-19 pandemic, unlike some of these other numbers that we have here. So aerospace, a little bit of a drop, and that's understandable when you think about all the flights that were grounded and what happened to that industry that the aerospace manufacturers are supplying. And then the other two categories that saw a better than average performance, pharmaceuticals and food and beverage, basically essential businesses if you think about it. So that's not surprising either. We also looked at the monthly change. So this is monthly consumption for all industrial customers in Connecticut. The blue line is the historical average, and the green line is the 2020 number. And the data is lower in 2020 every single month. And you see that big drop off in April when the economy shut down. We also looked at that same graph, but we removed the large customers. So that's what I have here. So again, it's all industrial customers in Connecticut. comparing 2020 usage to the historical average. And in this chart, you'll see that the numbers were actually pretty close to the historical average at the beginning of the year. And then we do see that big drop off in April, although it's not as significant as it was on the previous slide. This time it's just the large customers. You can see relatively flat compared to the historical average. And if you isolate just the food and beverage manufacturers, you get this. So in this chart right here, it's actually higher every single month in 2020. So these are food and beverage manufacturers. And it does make sense in the COVID-19 context when you think about it. So, restaurants are closed, grocery stores and convenience stores are still open. Everybody's doing all the shopping that they're doing, cooking at home more than they normally would. So it's not surprising to see that this is an industry where we saw an increase based on its historical average. Now, as part of the research, we also looked at an individual customer and did a case study on that customer. And we tracked its data against some of the same charts that I've already shown earlier in the presentation. And when it came to working with customers during the pandemic, it was interesting. It was a lot of a sort of a case-by-case situation. We had pockets of strength, and then we had pockets of weakness. In some cases, you'd see that big drop-off in usage, and that would be an opportunity to work with them. That meant that facilities were empty, and we were allowed to get into their site and actually do projects. In other cases, that drop-off meant no opportunity. It meant business was bad, and the customer would not have access to financing to invest in some of our programs. So it really was sort of a case-by-case situation, but we used those numbers, the monthly changes, to sort of as a signal to understand, like, who should we be talking to based on what's happening in the market. The case study customer, food and beverage manufacturer, one of the top quartile customers, and this happened to be somebody that we initially engaged after doing that first segmentation analysis to sort of understand who our customers really are. And they have done projects with us over the years, and we were successful in getting them to work with us in 2020 as well. So during the pandemic year, they were still interested in working with us. And this is a customer that's done electric projects and gas projects. So they've been comprehensive with their investment in the energy efficiency programs. Those penetration numbers that I was showing before, interesting to sort of consider them in the context of an individual customer and then comparing that to the category average. So that's what I have here. And I'm tracking it over our 3-year plans. So that's how we operate in both Connecticut and Massachusetts for our programs. This is a customer that at the beginning of our engagement was doing almost nothing. And you can see, very limited participation. So its penetration was near 0%. And then we started to work with them, developed a partnership. 2016 to 18, penetration jumps up to over 2.5%. And then, we've continued to work with them, and a little bit of a drop off in terms of penetration numbers moving into 2020, but still higher than the category average. So a very successful relationship that we've had with them. I also consider this end use analysis that I showed before. And in this case, the customer is getting 19% of its savings from lighting, whereas the category average for food and beverage is 29%. And given the circumstances, that would be considered a good result in that they're not relying on just the lighting measures to get savings. They're more comprehensive. They're doing a lot with process, steam traps, et cetera. So I think it was a successful partnership, but we use this data to understand who are the customers that we should be going after. So with that, I'm going to turn things back over to Margaret. And the last thing I'll say is that, this was a presentation that's very heavy on the data analytics piece, but that's just one part of a bigger platform that we use at Eversource to deliver our programs to our customers. We also have a huge focus on our internal skills and capabilities. There's the partnerships that we've developed in the industry, the technologies that we've developed, and then data analytics is a piece of that too, but it's really part of a broader platform. We're emphasizing it today because that was our paper as part of these ACEEE proceedings, but it's part of a bigger platform that helps us meet our goals and deliver energy efficiency to our customers. With that, I'm going to turn things back over to Margaret.
All right. Thank you so much, James, and for that really interesting discussion on segmentation and industry in Connecticut especially. I'm going to introduce our next speaker. John McHugh is a mechanical engineer and principal at McHugh Energy Consultants. In the early 90s, he started as assistant director at Colorado State University at Energy Analysis and Diagnostics Center. He developed a lot of calculations and commonly encountered now for industry energy efficiency measures. Since then, Mr. McHugh is focused on mass production of energy efficiency through energy codes, including Colorado Energy Guidelines, Canadian Model Energy Codes, ASHRAE 90.1, ASHRAE 189.1, Green Building Standard, and California's Title 24 building standards. Most recently, some of his projects include Energy Code strategic planning and developing an implementation plan for achieving widespread adoption of zero net energy and carbon neutral construction in California. So a big task there ahead of you, John. With that, I'll let John take it away.
Thank you very much. Welcome everyone to today's meeting. Last time I attended the Industrial Summer Study, it was in Niagara Falls in 2013. And back then, the focus was on energy efficiency with carbon reductions as a byproduct. And nowadays, with the climate crisis being so obvious, the focus seems to be that carbon reductions is the organizing principle, and energy efficiency is coming along for the ride. Today's paper is that I'm going to be talking about is building efficiency codes as a vehicle for deep energy reductions. My co-authors here are Yanda Zhang from Z&D Energy, Kiri Coakley from Energy Solutions, and Mark Alator from Pacific Gas and Electric. They are all members of the California statewide Codes and Standards team. Similar to what I was describing back in 2013, I'm revisiting a key thesis from 2013 and looking at it now. And one of the key issues was that we can mass produce energy efficiency, industrial energy efficiency through energy codes that can be applied not on a one-by-one basis, but on an entire sector. My career started out with, as was mentioned earlier, with the industrial efficiency assessments. And my perception is that these perceptions had two components. One was a highly specialized custom proposals, typically for large customers, similar to what James had mentioned. And then also a number of repeatable efficiency measures that you would see on a regular basis applied to the supporting utilities of steam, hot water, lighting, motors. And many of these those repeatable measures have been mass produced first off through the federal appliance efficiency standards. So, EPACT has requirements for minimum efficiency of motors, but my talk today is going to be around a parallel effort with building standards. So this was the paper back in 2013. And note that this paper is available on the ACEEE website as well as on the McHugh Energy website. Most of you, I assume, are familiar with the Industrial Assessment Center program, and there's 31 schools participating now. In short, these schools provide free industrial energy audits to small and medium manufacturers. In return, students and professors get unrivaled access to industrial processes and see how energy is consumed in factories. And for people like myself, students also get funding to pay their way through school. So it's an outstanding program. And one of the other benefits of the program is that information is also collected during these assessments. And this table is also from the 2013 paper. And what it is it shows the highest, the most frequent recommended energy efficiency measures from all of these industrial energy assessments. And in red, you can see in this case, all the this was a paper in 2013, how many of these efficiency measures were also being applied to the Title 24 energy efficiency, building energy efficiency standard. So one of the questions back in the day when we first looked at bringing process efficiency into building codes, there were concerns about how applicable it would be. Up to this point in time, process measures or process energy consumption was unregulated by the building code. And so there were a number of questions that arose. And one of the first ones is, why should this be in scope? Isn't this out of the scope of building departments? Are they really inspecting many of these equipment in factories? And the answer was the building departments are already collecting plan drawings. They are already inspecting factories for many of the building codes. So the National Electrical Code is part of the building code, as is the Mechanical and Fire Code. Another question has to do with how can you regulate on a energy code basis factories? Their processes are so different, and how can you come up with a repeatable energy efficiency requirement that is applicable to all factories? And the answer is similar to again, James's presentation, where they talked about common efficiency measures versus those that are specific to the particular end use or as a specific manufacturing process. And in this case, all of those utilities, the compressed air systems, the steam systems, etc., those are systems that look pretty much the same regardless of how that lighting or compressed air is being used. The other question has to do with, factories are complex. How can a local inspector inspect these very complex factories? Typically for these large factories, you have some of the same issues, that these factories are highly complex, and yet you want to make sure that the public and employees are protected. As a result, you typically have what's known as the inspector of record, and that's someone who has the training to look at these facilities. A lot of times they're actually a third party who are hired by the factory and then report back to the local jurisdiction. Also, for how the California standards are set up, there are what are known as the acceptance tests, and those are essentially commissioning of equipment that they are installed in line with the energy code's intent. And in those cases, the same people that have the skills for installing the equipment also then perform these repeatable tests that are designed to identify repeatable faults in the operating of the systems. The other question has to do with Many of these facilities are operating 24/7. They've got to make, they install equipment on the fly. And if those plants had to apply for a permit and wait for inspection, this would create unacceptable delay. Well, this is an issue that also applies for many of the other codes as well. And many of these larger plants have what's known as the annual permit that allows work to go on. The forms and the update to the local jurisdiction happens on a recurring basis, so that business is not held up. Now, in terms of the developing efficiency standards for building codes, industrial standards for building codes, it takes a lot of time and effort and expertise to develop these proposals. For California, the process has been is that the California investor-owned utilities, as part of their energy efficiency programs, have since about 2000 have developed a codes and standards program. And that program, and the idea is that the efficiency the utilities are required to pursue energy efficiency options that are less expensive than purchasing a new power plant. So there's benefits to the consumer in terms of lower costs as well as to the environment. And this program has ramped up over time, so that at this point in time, the program accounts for over half of the energy savings for the total efficiency portfolio, while consuming less than 10% of the budget. So if all these industrial efficiency measures end up in building codes, is this going to put the industrial programs out of business? And the short answer is no. First off, there are many situations that are not amenable to energy code enforcement. So first off, the energy code does not require that people pull out equipment and replace it. It impacts new construction and alterations. The efficiency programs or the incentive programs can still provide inducements for people to upgrade their equipment before it has failed to obtain the savings in the short term. In addition, in advance of an energy code taking effect, those inducements help smooth the path towards code adoption by having the market prepared and commercializing of the various measures that are being considered. And then finally, the other efficiency programs help fill the pipeline with new efficiency measures for the next generation of energy codes. So there's lots of opportunity for a well-integrated efficiency portfolio. And so what is the effort that's, in terms of the advocacy effort, the Codes of Standard program provides information to the California Energy Commission so that they can have the background information for making an informed decision about the policy decisions that the California Energy Commission makes. And besides developing these proposals, the CASE team also holds stakeholder meetings so that there is feedback from the affected market how this would work out. And that's in addition to the public workshops that the Energy Commission holds as well. The key thing to note here is that all of these proposals are available on this website, title24stakeholders.com. So you can look at all of the background information, the energy savings, the market share issues, the costs, the savings, and cost effectiveness, which is critical. This table here shows the industrial energy efficiency measures by energy code year. So the standards typically get adopted every 3 years, and shows the energy savings and also the carbon emissions reduction. And these savings are in terms of what are the savings for that first year's new construction and alterations. So that if you took these numbers and said, well, okay, but I'm looking at the whole code cycle, you might multiply these by 3 years, or actually just moving forward in time for those efficiency measures. The other thing to note is that there are substantially more measures that were adopted in 2013 rather than the other years. And that had to do with, reflects the Energy Commission's availability and priority. And it's worth noting that in 2016 and 2019, there was a lot of focus on residential energy efficiency as the state was updating the standards to more closely match the statewide goal of all new residential new construction being Z&E or near Z&E by 2020. For the 2022 standards, which are still in process, but we're most of the way through this code cycle in terms of adoption, this table lists the measures that were evaluated for this code cycle and we believe are going to be adopted. The things to note here is controlled environment horticulture. This was the largest measure for this code cycle, and it reflects the market realities in California since 2014. Cannabis, I'm sorry, 2016, cannabis cultivation was legalized in the state, and there's been a massive growth in of growing cannabis indoors, and so this focused on indoor lighting and dehumidification. Next measure here was from a prior efficiency measure where the threshold was dropped from 5 to 10 million BTUs per hour, and this was the O2 trim for process boilers. It's the automatically adjusting the air-fuel mixture based on the measuring of the flue gas components. Refrigeration system opportunities. These were primarily associated with newly regulating transcritical CO2 refrigeration, as well as updating acceptance testing requirements. Compressed air piping and monitoring. So pipe's not leaking, the pipe is appropriately sized, and the system is being monitored. Steam trap monitoring and computer room efficiency. This dealt with economizer set points, uninterruptible power supplies being qualifying for the Energy Star efficiency levels. And the thing that's worth noting is the shaded rows on the bottom of this table. All of those measures have paybacks, simple paybacks that are longer than 2 years. Approximately half of the energy savings from the efficiency measures in this code cycle are longer than the two-year simple payback. And that's because we are the energy efficiency standards, their cost effectiveness is evaluated on a life cycle cost basis. And similar to building standards, this can result in energy efficiency measures that have longer paybacks than what might be chosen otherwise. But there's still energy savings in terms of, reducing life cycle costs on a life cycle basis. So just briefly, for controlled environment horticulture, this was specifying a higher efficiency lamps that are evaluated in terms of their photosynthetic photon efficacy, and that has to do with the region of the spectrum that promotes growth. And it's a public process, and originally we had wanted to propose that LED lighting be used indoors, but we received enough negative comments from growers that they felt that this negatively impacted product quality. But we still were able to save a significant amount associated with the efficiency of higher efficiency HID lamps. The main comment here about steam trap monitoring is that when steam traps fail, they essentially have a steam leak, but the steam leak is inside of a pipe. The leak happens through the trap, and the steam goes back through the condensate system and is released to the environment through the deaerator tank. So this is a loss that's essentially invisible to the operators of the plant unless they're going around and doing testing. The proposal here was to monitor steam traps for newly constructed plants and large process expansions. For compressed air, we're building on many of the measures that were already that were adopted in the 2013 code. And we first start off with some relatively simple ones related to pressure testing of compressed air piping, similar to how natural gas piping is tested. And then also requiring the monitoring of large systems. Also, again, building on the 2013 standards, large systems are already required to have sequencing controls. And this one would require monitoring, which would allow for evaluating of growth of leaks, as well as controls problems with the equipment. So the national industrial emissions for the U.S. are about 20 times that of California. The global industrial energy emissions are around 5 times of that, or basically 100 times that of California. So I'm sorry, 50 times that of, 100 times that of California. If we just looked at the, the industrial energy consumption and scaled up the savings to the United States, the savings that have been possible in California, we'd be looking at these large numbers that are described at the bottom of the slide. Here's a list of potential future measures. Some of these are expanding this. So for instance, steam trap FDD, applying it to replacements and alterations and not just new construction. Looking at higher efficiency lighting, and I guess I won't read these because you can read these. But anyway, these are variety of different measures that, some of them are building, basically consolidating the gains that we have from prior code cycles, and others are new measures. There's several national model codes that have process efficiency measures, both in ASHRAE 90.1 and in the IECC. Now, you may not be able to see that, but that's actually a carriage bolt, and a hammer is not a very good way to install a carriage bolt. So even though we're able to mass produce energy efficiency through energy codes, there are just certain places where energy codes are not necessarily appropriate and that other measures should be considered. So one thing to note is that there are a number of efficiency measures that are federally preempted, and that places a huge barrier. And in terms of a policy presentation, I think it's important for folks to realize that there's some pent-up energy efficiency opportunities that are constrained by the federal preemption laws in terms of preempting states from going further past the minimum federal efficiencies. The other thing is even though the controlled environment horticulture was one of our largest efficiency measures, and we're saving somewhere on the order of around 20% of energy consumption. The reality is that growing indoors uses about 20 times as much energy on a per unit base, per unit of production basis, as does growing outdoors. And unfortunately, right now, the laws are set up to encourage growing plants indoors. So potentially there's the 95% savings if state and federal policy allowed or encouraged outdoor growth instead of indoor growth. So in conclusion, energy efficiency measures, So in conclusion, we can mass produce energy efficiency through building standards. The 2-year simple payback can be broken, and it allows for a large expansion of savings. These are also achievable on a state and international basis. So hopefully some of the information provided today leads to process energy efficiency standards in other states or nationwide, and bringing that this information is available at title24stakeholders.com. Thank you very much. If you have any additional questions, please feel free to contact me at john@mchuenergy.com. Thank you.
Hello, everybody. Thank you, John, for that great presentation and a lot of the nuances that California is facing in its industrial sector, and how to mass produce energy efficiency through code. We're going to move on to our next speaker, Rob Newman. Rob, I've had the pleasure to work with myself. He focuses on energy efficiency evaluation, developing technologies and changing markets. He's worked in energy and telecom for many years. And he's worked with a lot of growth companies, consulting public utility practice groups, and really just across the utility and energy landscape. Includes developing strategies for advanced utility technology, energy efficiency, and DSM programs, cost eval, delivery models, and related legal and regulatory issues. He's worked across gas and electric, and his recent energy evaluation experience includes multiple year evaluations for Illinois' largest electric utility, natural gas energy efficiency portfolios for the Midwest and other U.S. Utilities. This also includes impact and process analysis, cost effectiveness modeling, and bidding energy efficiency savings back into the PJM. He provides advice on application of various state energy laws and is also involved in clean energy policy, where he advises clients on evaluation of renewables, EPA, and related regulatory rules. He's also worked on multi-year FTC oversight matters involving some of the largest U.S. utilities. He's also worked for FERC, or his work has gone before FERC, DOE, EPA, FCC, and his work has touched South Carolina, Kentucky, Georgia, Texas, Michigan, Illinois, California, Minnesota. Looks like about half the U.S., Rob, that you have affected some outcomes. And he is based here in Chicago with me. We attended the University Chicago Booth School, Kent School of Law, and University of Wisconsin-Madison. So Rob, I'm going to hand it to you to talk about some of your work as well.
Me?
We can hear you.
Great.
And we can see you. Go ahead and share.
Perfect. I am sharing the screen. Can you see it? Can you see the screen? All right, I'm going to start. I can't hear anyone, so I'm hoping you can all hear me. I'm presenting today on statewide stakeholder governance and fostering energy efficiency savings and GHG reduction through new models for energy efficiency across the states. We came across this abstract in our analysis and working with various utilities across the country and realizing that there were sort of standard approaches across energy efficiency and structures. And then there are different ones. Those are starting to break away from the mold. And so energy efficiency programs are generally overseen by state utility commissions and implemented by utilities. Most states rely on commissions to develop policy and improve savings. A key to fostering growth in programs is to understand how to manage the energy efficiency program process beyond the traditional state utility commission regulatory oversight model, which has proven effective, but not for possibly not for ongoing growth and for future needs around reducing carbon and GHG. So the process can be applied to leverage energy efficiency programs for carbon reduction and GHG reductions, as well as reducing demand, as we've done with current energy efficiency portfolio models. So there are regulatory approaches that have started to break away from the traditional model. And those specific examples include California, Illinois, Massachusetts, New Hampshire, Wisconsin. Those are the primary ones. These models can be used for other states to help move toward greater savings as well as reduce GHG. So each example is different, and we're going to talk through some of them. So energy efficiency is implemented across many states today. 6 states have energy efficiency goals or pilot programs. 24 states and the District of Columbia have legislated resource standards, and 7 states have adopted or extended energy efficiency policies since 2016. There are some states that are moving sideways or backwards, some would say. So the exceptions are Indiana, Ohio, which have retreated on energy efficiency goals since 2014. And we'll get into that a bit. So one of the big points I'd like to make, and this is known but not necessarily talked about, and maybe it's the white elephant in the room, which is there is a disjointed energy efficiency approach that's mostly due to the lack of national U.S. energy policy. So we have U.S. energy policies and legislation, some of which are listed here: Public Utility Holding Company Act of 1935, which has been on the books many years; Energy Policy Act of 2005 addresses energy production in the U.S., Federal Power Act of 1920, which is ancient at this point; various national laws that establish the Nuclear Regulatory Commission, FERC, EPA, et cetera. But there isn't a single driving policy to reduce energy efficiency and GHG. This is the map that depicts what I was just talking about. So 6 states with energy efficiency goals or pilot programs are shown here. And then there are 24 states plus DC with energy efficiency resource standards. And those are sort of in some ways the leading states because they have goals and their commission oversight, and there's hearings, et cetera. So utilities, the largest utilities in those states comply with those rules, et cetera. 7 states adopted or extended policies since August 2016. And as I noted, as of 2014 and 2020, Indiana and Ohio began rolling back its EE standards, which is another topic, and we can address that, but you can see there on the map. So some strong states, and not necessarily the strongest, but examples of strong states are California, Illinois, Michigan, Massachusetts, Oregon, Vermont, which implement energy efficiency and evaluation through legislated and commission policies. These states provide strong models that we all can follow or implement in some form. Each of these states have cost recovery and detailed evaluation policies and approaches. Many states have had policies in place for many years, but not necessarily legislated requirements. So it's, some of them are just actively overseen by commissions, and that works too. It doesn't necessarily have to be legislated. So some of the effective states include Connecticut, Pennsylvania, New York, Michigan, Massachusetts, Arizona, et cetera, which are stable states and have EM&V approaches and policies and track records. Arkansas is notable since it's in the South and Southeast and the South, in which where EE isn't so strong, but they have established EM&V policies and procedures, and they have a technical working group and a TRM, and which I'll talk about a bit more. So Arkansas is a standout state. And then some states in flux, as I noted, Iowa, Indiana, Ohio have historically achieved energy efficiency savings and have done well, but those are trending backwards. So in 2014, Indiana, and 2020, Ohio, the state legislatures reduced or eliminated energy efficiency resource standards. Utilities are expected to continue, but it's just commission oversight and it's not required. And one example in Iowa in particular, Iowa allowed use of a ratepayer impact measure cost effectiveness test, which typically comes up with a negative cost benefit answer, which is not good. That means they can disallow programs because it's not cost beneficial. So it's those sorts of things that are being used to backtrack on energy efficiency as a leading resource or an effective resource, and that's in Iowa. So each state establishes its own regulatory structure for implementing energy efficiency. Only 30 states have some type of established goals. Utilities in many other states offer E programs, but they are not required by law or regulation. States have established various initiatives to promote the development of programs. Legislative and regulatory oversight varies greatly by state. Many states have degrees of energy efficiency legislative or regulatory policy activity, but not necessarily full throttle, where we, as compared to some of the what we call leading states like California, Massachusetts, Illinois, et cetera. So the fact that many states have policy in place, but we're hoping it can become stronger. So the level of specific requirements, length of energy efficiency in each state, and the type of incentives and penalties differ widely across all the states. A comparison I'd like to bring up is in the EU, which is a possible alternative to the state-by-state approach. And again, back to my initial point, one of my initial points, that we don't have an overriding energy efficiency policy or energy policy in the US. The EU 2007 targets were set to cut annual energy consumption by 20% by 2020, and they did meet that goal. It was further expanded to 32.5% by 2030, and they're moving diligently to that goal. The goals are mandated across all EU states. There's a unified approach with rules that allow each member state, MS state, to implement plans to reach individual goals. The goals appear to be working, and energy efficiency measures are used to achieve energy supply needs and cut GHG and promote EU economic competitiveness. So here's some back to the US, and I'd like to keep the EU example in the background. Back to the US, we do have cooperative state approaches which have been proven to be very effective. Here in Illinois, I'm based in Chicago, we have what we call the Stakeholder Advisory Group, the SAG. And this is a consortium of the utilities, the gas and electric and gas utilities that are required to adhere to the legislation in the state. That means ComEd in the north, Ameren south of ComEd, which are the largest electric utilities in the state. Ameren is dual fuel, it's electric and gas. And then we have the largest gas companies as well, which is Ameren, as I noted, it's dual fuel, Peoples, North Shore Gas, Nicor Gas, and each company is required to implement energy efficiency programs. But this has also led to jointly managed utility energy efficiency programs, for example, and consistent ICC policy. It's very effective. The decisions and some of the methodical lessons learned and things implemented in decision from the SAG are implemented and approved in an efficient manner by the Illinois Commerce Commission. So it's greatly reduced risk for the utilities, and it's brought certainty to the process. In Arkansas established a permanent statewide collaborative in 2006, and with an expectation that it would evolve as the issues continued around and evolved as they move forward. It's called the Parties Working Collaboratively, the PWC, Parties Working Collaboratively. They initially focused on a narrow set of issues, and its role expanded as the commission and the participants realized the value. So that in Arkansas, you have a similar process to SAG, although it's set up differently and the parties interact differently. But again, it's a cooperative process. And then some other examples of cooperative approaches include California, where the PUC in 2008 adopted the state's first long-term energy efficiency strategic plan. Massachusetts created its joint statewide effort and published the joint statewide 3-year electric and gas energy efficiency plan. That's been recently updated in 2019, and that's been going on for many years. New Hampshire has a statewide planning process, not too different from Massachusetts. It would look similar if you were looking in from the outside, definitely nuanced differences in the way they manage it, and its implementation and evaluation effort for electricity and natural gas programs, and the utilities involved file a joint 2-year plan. So it's a 2-year process as opposed to a 3 or 4 year process as in other states. And Wisconsin, for example, created Focus on Energy, which is based in Madison and operates throughout the states, and the largest utilities are involved, which is a consortium approach to delivering energy efficiency, and it's very effective. So there are different cooperative approaches when you look across the states that do different things. Some focus more on policy, others focus more on implementation, but they're all highly effective, and the utilities involved are generally quite pleased with the results. At least that's my opinion, looking in from the outside and working with them in a number of instances. So what I would like to move to, and this is sort of the impetus for this discussion, is GHG reduction and new models, right? So we have demand reduction for energy efficiency. And what we need to do is leverage energy efficiency, in my opinion, leverage energy efficiency for GHG and carbon reduction, as they're doing in the EU. So as I note, a key difference between the EU and the US on energy efficiency policy is that there's an overall EU directive to reduce GHG by 20% by 2020, which they have done, and 32.5% in another 10 years, and by 2030. Each nation chooses to adopt the EU directive or choose alternative policy, but they're generally marching in that direction. A great deal and we don't have this in the US. So some key points. A great deal of the change in resources and models is due to the global movement, as we know, away from central station generation to reducing carbon and GHG through renewables and implementing energy efficiency and other resources. To that end, many states and nations are looking to energy efficiency to reduce energy demand, while we should also use it for decarbonization, as they do in the EU. The US leverages energy efficiency mostly for energy savings reductions and not for GHG reduction as they do in the EU. Their exceptions include California and the RGGI states. RGGI is the Regional Greenhouse Gas Initiative, and the states that are part of RGGI are listed there on the page. And it's highly effective, and to date, RGGI is slowly expanding, it appears, too. I believe they just added Virginia in the past year, approximately. So it has been successful. So in California, GHG reduction models, using California as an example, in July 2017, California state legislature passed Assembly Bill 398 to reauthorize and extend through 2030 the state's economy-wide GHG reduction program. The bill sets a new GHG target of at least 40% below the 1990 level of emissions by 2030. As of 2015, about 86% of California's GHG emissions were related to the consumption of energy, which is, as we know, quite a bit. The California Energy Commission leads the state in establishing rules and regulations for implementing energy efficiency, specifically for appliance energy regulations, building energy efficiency, energy supplier reporting, and state energy management. A key point is an executive order for California's governor, from the governor, targets an 80% reduction from 1990 levels by 2050. I think that's within the last 2 years. A large portion of the reduction are expected to come from energy efficiency. A key point for us, California's emission cap and trade program, which started in 2013, is one of the major policies the state's using to lower its greenhouse gas levels. Now, the RGGI states is the Regional Greenhouse Gas Initiative states is the first mandatory market-based program in the U.S. to reduce GHG. RGGI is a cooperative effort among the states that we noted here and previously to reduce CO2 emissions from power generation specifically. The RGGI states are doing something very interesting. They implemented a new cap reduction trajectory of 30% over the period 2020 to 2030. The CO2 cap represents a regional budget for CO2 emissions. A key point is the third bullet, which is recent investments in energy efficiency funded projects are anticipated to save consumers over $1.2 billion on energy bills. This provides benefits to more than 115,000 households and 1,200 businesses. So it's significant. And back to the EU example, in the EU, energy efficiency deployment focuses, as I noted, on decarbonization in the power, heating, and transport sectors. The EU deploys EE to meet climate and energy goals since it recognizes that reaching these goals without EE is expensive, right? And implementing any sort of generation, including renewables, is always more expensive than energy efficiency. We know that. That's a proven point. The EU recognizes that substantial renewable energy would be required, which is more expensive than energy efficiency. And the building sector alone is identified as important to reaching this goal. Energy efficiency is expected to be leveraged after 2030 to reach future goals too. The energy efficiency is also seen as a key strategy ensuring the cost-effective decarbonization of the energy system. So what we're seeing in the EU and within various regions within the US, the RGGI states and California, is this recognition that energy efficiency is the least cost option, and using that as part of the effort to not only reduce demand, but also reduce GHG in a least cost way is imperative. This is the map of the EU and where the implementation is taking place. So the figure 2 here illustrates the current status of implementation of energy efficiency obligation schemes, EEOS as they call it, across the EU. So these are the member states where they're a part of the program, the 2017 rule that I noted. The EEOS are the most important policy. It's the most important policy instrument for energy savings and carbon reduction in the EU. At least 17 member states plan to implement or have already implemented an obligation scheme, and approximately 40% of the proposed savings. 4 member states have notified the EEOS as the only policy instrument for Article 7, and others are moving forward. So it's in process. It's only in the 4th year at this point, but there's already been success. So some concluding points. New approaches and models are essential to foster the global movement toward new energy resources, energy efficiency, renewables, storage, etc., and reduce energy demand while also reducing GHG. Multiple year energy efficiency plans, collaborative, regional, and statewide efforts are imperative to improve and increase energy efficiency deployment. Fostering development of statewide energy efficiency program oversight and development will require incremental state regulatory changes and new ideas for cooperation between utilities, stakeholders, municipalities, and other parties. This process can also be used to leverage energy efficiency programs for carbon and GHG, as I noted. The EU, California, and RGGI states have recognized, acknowledged EE as a way to reduce demand in GHG overall. This is very important. Agreeing to national energy goals would be an important step toward fostering market model changes and large-scale movement towards GHG reduction in the coming decades. Thank you for everyone's time.
All right, excellent. Thank you, Rob. That was a great segue into the Q&A to kind of talk a little bit more about how kind of local and regional policies and programs, maybe some lessons for national and global. If the producer can move our panelists onto the screen, Rob and John and James, excellent. So again, for the audience, if you have questions for any of the speakers, just put it in the chat on the right-hand side. At the start of James' presentation, we collected a few. But I'll also have a few handy. So James, let's kick it back to you to start. And let me pull up some of those questions. A few of the questions that came up, let's see here. Sorry, I have to expand so one clarification or one question for James. Are the COVID impact numbers in your presentation absolute, or were they based on, let me see here. Sorry, I've had to minimize onto one screen. Were the COVID impact numbers in your presentation, James, absolute consumption or normalized based on relevant indicators, e.g. production?
So I have an answer to that question, but I don't think it's the answer that the question is trying to get to. But I guess short answer is that they're absolute consumption numbers. We did normalize the monthly usage. So the monthly consumption charts that I showed were calendar normalized. We don't have AMI infrastructure in place as of yet. So we had to do a calendar normalization exercise to ensure we had the right usage attributed to the right months in the charts. So that was a normalization exercise that we did do. But as far as the rest of it, yeah, it was basically the absolute build usage consumption numbers. It did not consider anything like production. I think to get to that level of granularity, we'd need some, I believe we'd need some data from the actual manufacturers.
Very good. So yeah, sometimes limiting without that AMI. John, we had a question for you. A couple of times you referenced federal preemption. Can you explain that when it comes to kind of the state versus federal? Can you explain that concept a little bit for the audience?
Sure. So the federal, can you hear me, by the way?
Yes.
Okay, great. The federal appliance efficiency standards, as part of those standards, there are two aspects of federal preemption. One is that the states are not allowed to set parallel efficiency standards, even if they're higher. So one of my colleagues, Alex Chase, and I wrote a paper for ACEEE for their summer study in buildings a couple of years ago called the federal appliance standards should be the floor, not the ceiling for energy efficiency. So, so first off, states like California, large states like California have their own appliance efficiency standards, but they are preempted from setting standards for anything that the federal government has covered. The second thing is that as part of that law, states are also prohibited from requiring higher efficiency equipment than the minimum federal efficiency in the state building code. So the basis for the efficiencies of equipment that are in the building standard, as well as the efficiencies of equipment that are in a performance standard. So if you have a building simulation and your simulation tool, and you're looking at setting a baseline that the building has to be more efficient than your actual building that you're simulating, again, the baseline has to be based on the federal minimum efficiencies. Additionally, federal preemption disallows you from actually setting your performance standard based on carbon. It has to be based on either energy or cost. So there's a number, for folks that work in building standards, we actually spend an inordinate amount of time trying to work around the federal appliance standard preemption requirements.
John, that's a kind of a great explanation and points out something that Rob touched on as well, which is this local versus national disconnect. And Rob, I'm going to ask the question to you, but kind of expand it to the group if everybody can kind of take their own version of this. For Rob, would it be possible to create a federal SAG stakeholder group or energy trust? Would it be valuable for states, from the states to the federal? I'm going to kind of ask you to talk about that. How could we take this local policy and adopt it nationally? But overall, each of you, if you can kind of look at some of the work that you've done from your presentation or just from your local experience, what are those local policies and programs that you would like to see expanded and adapted nationally that you think could make a big difference?
Right. So I think the simple answer, straightforward answer is, can we have a stakeholder group at the federal level? I think it would have to be very informal. It wouldn't be rubber stamped by a federal agency at this point. And one thing I didn't get into, but I think you all read between the lines, which is, it's all very political. The reason we don't have a national federal policy is because of politics. And that's why energy policy and legislation develops at the local level, the city, state level, and is developed that way. So point number two, I think we can leverage the western states and the eastern states around RGGI, and California on its own probably could bring in Nevada and its other neighboring states to create geographical groups. And that actually probably would make more sense than a national SAG, right? A stakeholder group, since the nation is so different and there's different requirements and different generation sources and resources across all the regions. So the short answer is no on the federal group, but yes on smaller regional groups that could help implement policy.
Great. And to you, James and John, local policies or programs that can be perhaps adapted that you think could be impactful, that you've learned through your career, or particularly this paper and this case study, particularly as it relates to industry?
Jim, do you want to start or should I?
You can take this one if you want.
Okay. So just first off, in terms of the purpose of the paper was to present to a national audience that there are many of these efficiency measures that we've adopted in California that could be adopted by the national model codes, such as ASHRAE 90.1 and the IECC. The thing to note is that federal preemption, besides being a problem, as described, you also want a situation where the states are also, the crucible of innovation. And just as an example, the electricity costs in California are 2 times that of the national average. So something that might be cost effective in California, you wouldn't want to be limited by a national energy code that said, well, you know, on average, you know, it's kind of like the two economists shooting, you know, shooting into the left and the right of the bird, and they said, well, on average, we shot the bird. But the issue is that you know, different states have different needs. There are states that have very hot climates, some that are very cold. Yes, energy codes address that with climate zones, but in terms of costs, you know, the states that have high energy costs and have, you know, climate goals, you know, you know, a federal requirement outside of being a baseline. So, you know, again, it being the floor and not the ceiling, that's a great idea. Thanks.
James?
Yeah, and I guess, you know, coming from another part of the country that has very high energy prices, I certainly can share that point. I would say in terms of policies that have worked really well, that would be great to scale them up. I think about our efficiency policies. So we have, you know, big emphasis on making sure the programs we offer are available to everyone. So we have our industrial customers that we're talking about today, but then we also have our income eligible programs and our residential programs. And we've you know, working with our regulators, working with our partners, we've done a lot of work to make sure that those programs are easily accessible to every single customer that we have as a utility. And I think that's the type of program that you want to take nationally, make sure that it's available to every single type of home and every single type of business.
Great.
You know, another thing related to, you know, availability to everyone, building standards are available to all segments of the market. So, you know, especially for renters, these standards sort of sever the split incentive issue in terms of, well, landlords also have to comply with the building standards. And, you know, typically, you know, incentive programs, you know, there are barriers to access just in terms of, you know, there's typically, you know, a certain threshold of size at which, you know, below which or above, yeah, below which it's somewhat uneconomic to serve. And so it's one of the advantages of sort of these mass produced programs, whether it's, you know, there's certain incentives that are, you know, that are upstream, but, you know, the energy code is one of those sort of upstream efficiency methods of outreach to the general public.
Great. Well, we just have a couple minutes left. I wanted to thank everybody. If we get cut off here, to each speaker. One question I'll leave you with is, you know, James, I think your data pointed out most specifically that a lot of our energy use is in a relatively small amount of users when we start targeting an industry. Each of you talked about the importance of listening to and engaging with stakeholders in order to improve policy and programs. You know, what are some of the high-level takeaways that you think need to be top of mind for policymakers, program designers, when thinking about industrial clients, industrial stakeholders?
I mean, I always go back to the data. Just understanding who your customers are, understanding where they are, monitoring the trends. With COVID-19, right now we're seeing a lot of commercial real estate downtown that's just completely empty, and now it's getting converted into lab space. And you know, that's a huge industrial category that we want to make sure that that's part of our incentive program. So, you know, to the extent that you can understand where the opportunity is using data analytics, I think that's my biggest takeaway from this session.
Yeah, that's a great point. You know, I think all the programs that we've talked about all require information, and you know, the type of, you know, that's one of the advantages of programs that are on site is they actually get to understand what are the key issues that are driving decisions around energy efficiency. So whether it's survey and outreach, you can't get to the same level of depth that you get when you're actually on site and you have an extended project.
Rob, I'll give you the last word.
Thank you. No, and I would add to all that. I couldn't agree more, John, James, with your points. I think setting minimum standards at the federal level, even if they're low to begin with, mandate requirements for implementing energy efficiency across all sectors and keep it simple could pass. And I think that would be a very important goal, even if it's simple and lower than everyone wants, but at least a starting point. And I think the benefits and economic benefits, as we know, would be visible pretty quickly.
Great. Well, thank you, folks, for joining, and thank you to the audience for some fun questions and participation. And we'll see you at the debrief shortly after this, and we look forward to seeing some familiar faces and some new faces. Thank you, everybody.
Thank you.
Thank you, Margaret.